Hi everyone, welcome to part 3 of section 7.2, Laws of Exponents. So again, what I want you to be aware of is that we're really not investigating something drastically different from what you've already been studying with regards to exponents. We're really just starting to work with the idea that you can have a fraction in the exponent position instead of just an integer value. So the first thing that I want us to remind ourselves of is the laws of exponents. We've looked at these. So the first three would be our product, our quotient, and our power rule. So we're just going to talk about these really quickly just to kind of keep this refreshed. So please make sure that you do fill this out in your guided notes. So if we have a to the m power times a to the n power, notice that the bases are the same. So this allows us to basically say, I'm going to have a, and then with regards to the m and the n, we would do m plus n in that exponential position. Similarly, whenever our bases are the same with a quotient or a division problem, we can say that this is a, and then we would take our exponents and we would do m minus n. Remember that it has to go in that order. It's going to be top number minus bottom number in those exponents. The next one is our power rule. So if we have a and we're going to raise that up, we're going to take our exponent and raise it up to another exponent. This is the same thing as doing m times n in the exponent position. The last one that we have here is where you're multiplying two values and you're raising both of that, you're raising that entire product to an exponent. If we need to, we can kind of split that out, essentially, is what we're saying. So we can give that m to the a and to the b. So in this case, we could have a raised to the m power times b raised to the m power. We can also do this with regards to a situation with division, and we've already kind of discussed that. But just to kind of add it, and you might want to add this to your notes, if you have a divided by b raised to the m power, that is the same thing as a to the m divided by b to the m. Okay, so hopefully those are familiar. If not, I do believe I provided you an exponential guide from the Algebra Survival Guide. I would encourage you to go through and read through and maybe take a look at some of those examples. So let's move to our first example problem. Okay, so the problem that we're going to work with is 8 raised to the 3/4 power divided by 8 raised to the negative 1/6 power. So the first thing that I want to note here, and kind of thankfully, is that, would help if I did not erase my numbers, the bases match. So I know that I can do, my answer will have a base of 8. So the next thing that I want to note here is I'm doing a division. So I'm going to actually take my top number and I'm going to subtract it from my bottom number. Please note that when you are doing this subtraction, that this negative in your problem is not indicating the subtraction. You literally are going to do 3/4 minus, so you can kind of treat that division bar as almost like an overly exaggerated subtraction sign, and then minus that negative 1/6. So hopefully what you're kind of noticing is my denominators aren't the same, so I have to do a little bit of work here. So hopefully common denominator is kind of floating through your mind on this one. So between 4 and 6, there's a few that you could work with. I would say, for example, in this situation, I would work with 12. So if you go through your 4 times tables and your 6 times tables, 12 appears in both of those multiplication tables. So in order to do that, so in order to make a 4 into a 12, I would multiply that by 3, which means I have to multiply the top by 3. So this gives me a solution. 3/4 is the same thing as 9/12. You're essentially just expanding it out so that everything will work for you. Then we're going to do minus And then in order to make a 6 into a 12, I would have to multiply that by 2, which means to keep everything consistent, I have to multiply the numerator by 2. So this is going to give me a negative 2/12. Now what I can notice here is that I have a negative and a negative, so I can make those become positives. This now gives me 8 raised to, if I add this up, the 11/12. And there's my answer. So the next 3 problems are practice problems for you. What I would encourage you to do at this point in the video is to pause it, work on those problems to wherever you can get to. So whether you can finish them completely and confidently, or if you can finish them but kind of go, I'm not sure if I did this right, or if you can just start the first step. What I want you to do is give it a try and then come back and review the video. Please feel free to add additional notes for yourself, and then we'll go from there. Okay, so to begin, we're going to do very much so, I guess, something similar to what we've already been investigating, but instead of a division, we're going to go ahead and do a multiplication. So again, I'm noting, oh good, my bases are the same. If they weren't the same, then there's really nothing else I can do to it. But in this case, I know that my base will be 5. And then I note that I have a multiplication. So I'm going to do 1/4 plus 1/8. So the fun doesn't stop here, everyone, because we have unlike denominators, so we have to get it so that we have a common denominator. I'm kind of noticing in this one, 8 is probably going to work out the best for me. So I'm going to write that as my 5. And then I have to make that adjustment. In order to make my 4 into an 8, I'm going to have to multiply both the top and the bottom by 2. So that is going to give me 2/8 plus 1/8. My final answer will be 5 raised to the 3/8 power. And here is my solution. Can't go any further. The next one is very similar to the one that we just modeled. Okay? The only difference is that the base value now has a decimal in it. You just need to be aware that there's a decimal there. It doesn't mean that you have to do any extra work. Your base just so happens to have a decimal. No big deal. So again, the bases match. Phew. That's good. So I can go ahead and just drop that down. Now I'm going to have to do some kind of subtraction because it looks like I'm going to have to use the quotient rule. But maybe you're kind of thinking, I don't see any sort of exponent in the numerator. Well, there's a reason. If you don't see the exponent, what does that mean? What power is actually hanging out up there? And hopefully you're saying it's the first power. So I'm going to have this as 2.7 raised to the 1 minus a negative 1/6. Again, I need to write this so that I can simplify my exponents. So first off, I can write 1 as a 1/1 just so I can make it look like a fraction. And that's going to be minus a negative 1/6. Again, a common denominator between a denominator of 1 and a denominator of 6 is going to be 6. So I'm going to multiply the top and the bottom by a 6 for my 1/1 fraction. So that's going to give me 2.7 raised to 6/6 minus a negative 1/6. And again, you can always check with yourself. So if you reduce 6/6, does that take you back to your original value of 1? If it does, then you're good to go. So my final solution will be 2.7 raised to, well, what we want to note here is that a negative and a negative together will make it positive. So this is going to be raised to the 7/6 power. And again, here is my answer. Last one, we're going to start to incorporate that idea of the last rule that we were looking at. So again, this time my bases on the inside are different, so I have to keep them separate. A base of x is not necessarily the same thing as a base of y, so they need to be kept separated. but I can give that 1/4 to each one of these powers. So now I'm going to probably expand this out a little bit more. I'm going to have x raised to the negative 1/3, and that's going to be raised to the 1/4. And then I also have my y raised to the 2/5, and that's being raised to the 1/4 power. Well, at this point, what exponential rule does it look like you're going to have to use here? Product, quotient, or power? I'm noticing that I have a power raised to a power here. So I'm going to have to use the product rule, or sorry, the power rule. I always end up switching them when I'm talking. We're going to use the power rule in order to correct this, or to simplify this down. So I can have x raised to, let me be consistent with my coloring, x raised to the negative 1/3 times 1/4, and then y raised to the 2/5 times 1/4 as well. I'll actually be consistent too. I'm changing out my division bars. I'll try to be consistent. Apologies. There we go. Everything's lined up now. So for the first one, we have x raised to a negative 1/3 times a 1/4. That would give me a negative 1/12. And then for my y's, I would have 2/5 times 1/4. So what I want to note is I can actually reduce. So I can cross reduce here. So that would end up giving me a 1/10. And if you did not note to cross cancel before you multiplied, you would just want to go ahead and multiply your fractions through and then see if you can reduce that final fraction down. Okay. So lastly, the only thing I can think of is if I wanted to write this so that there were no negative exponents. So my x is unhappy. So what we're going to note here is that my y value is good, but I'm going to have to move my x raised to the 1/12 downstairs in order for it to have a positive exponent. And once again, here is my final answer. I hope that was helpful. If you do have any questions, please let me know.